Oh, okay.
Atëherë, përshëndetje. Ju falenderoj që jeni pjesëmarrës në këtë takim tonin virtual, as pak të zakonshëm. Gjithsesi, edhe takimet virtuale shërbejnë për të komunikuar, për të njohur me njëri tjetrin dhe së shpejti shpresojmë të kemi edhe një takim real në Tiranë së shpejti. Për sa i përket Albanian Role Models, është një seri eventesh të cilët fillojmë hapim si parin sot dhe do kemi një sër gocash grash të cilat kanë dhënë kontributin e tyre në teknologji. Dhe fillojmë së pari këtë event, pra ky event ka si qëllim kryesor jo vetëm të promovoj, por gjithë nëpërmjet promovimit të sillim shembull të cilët kanë arritur sukses për sa i përket fushës së teknologjisë. Dhe në të njëjtën kohë të shërbejë dhe si një webinar ku secili nga pjesëmarrësit, pra nga të ftuarit speakerët do jap një prezantim për sa i përket një teme të caktuar. Gjithsesi, gjithashtu doja t'ju ftoja, jam duke bërë share tani në chatin ton, disa pra emailin e Women Tech Maker, ku mund të na shkruani nëse kërkoni të organizoni evente të ardhshme ose nëse doni të jeni pjesë e speakerave. Eventin ton ne kemi një komunitet, sepse jemi së bashku me GTG Tirana, dhe aty kemi një event, një komunitet tonin, një komunitet i cili është gjithkohës aktiv dhe mund të merrni pjesë atje, të merrni gjithë informacionet e fundit për teknologjinë në Discord, gjithashtu mund të bashkoheni në Facebook, LinkedIn, gjithashtu edhe në Instagram, për të parë se si do vazhdoj si pari eventeve të tjera. Jemi në fakt të nderuar që Ornela bashkohet me ne, e hapim si parin me të një sër eventesh. Nuk dua të zgjaten shumë për sa i përket backgroundit të Ornelës. Ajo do jap disa informacione bazë për sa i përket backgroundit të saj, po ajo është një fellow master PhD të programit të Marie Curie, ndërkohë që ka një background extended për sa i përket researching, kryesisht siç e tha data processing për sa i përket në fushën e mjekësisë të dhënave mjekësore, por gjithsesi do jap pastaj të drejtën të vazhdoj të shpjegoj më tepër. Kështu që faleminderit dhe gjithashtu është shumë e rëndësishme t'ju përmend që 10 minutat e fundit, 10-15 minutat e fundit, secili nga ju është i ftuar që të bëjë një pyetje për sa i përket sesionit të cilin kishim online, nëse keni pyetje të drejtpërdrejta për Ornelën, qoftë për karrierën e saj, qoftë edhe për speaking, për atë talking që ajo është duke bërë tani. Faleminderit. Po ja lë asaj të drejtën e fjalës.
Përshëndetje, unë tani do shall we switch to English or keep it o ta mbajmë në shqip?
I would prefer English because I see there are some international
okay.
participants, so that would be
perfect. I'll switch to English then. I'll share my slides now. Can you see my screen? Okay, perfect. So welcome everybody to this webinar, and thank you guys from the Women Tech Makers Albania. I am Ornela Bardhi, and I will be talking about data preprocessing with Python. A little bit about me. I graduated here in Albania. I did my bachelor's in computer engineering, and I did also an exchange during my bachelor's in City University London in UK. After that, I came back to Albania and I graduated, which is very important, and I started my master's in electronic engineering. However, I wanted to continue to broaden my experience abroad, so I did a joint European master program in Pervasive Computing and Communication for Sustainable Development, which was in 4 different countries, in France, Finland, Russia, and Sweden. During this time, I co-founded and founded 2 startups, one in Finland and one in Sweden. The one in Sweden was a spin-off of my master thesis. However, because I like doing research a lot, so I stick to research. That's why I started my fellowship with Marie Curie. And so I moved to Spain, where my main host institution is. However, I did research visits in US, in Ireland, in Finland. I have to say that during my PhD, I've worked in academia and also in industry, and also in healthcare. I did a study in Ireland, and I will talk a little bit about it as well. I am also board member of Marie Curie Alumni Association of Western Balkans Chapter. Before I start with data preprocessing, I wanted to talk a little bit about data collection because that is very important. I edit here manual and automatic data collection. However, these are not scientific terms. I wanted to say that sometimes you have to collect the data yourself, so you have to do field work or experiments in general, and sometimes you can get the data from somebody else or another institution via online repositories or by contacting other institutions in general. However, in both cases, although the first one, manual data extraction, collection, you usually know the field and you want to extract the data that you really need for your study. In the second method, automatic data collection, you usually use the data that is already there and collected by somebody else. However, you might have different hypotheses or problems that you think that you can solve by using that data. However, it is very important to collect the data you need and not the data you think that you might need. These are some useful libraries that you will be using if you're doing any kind of data analysis. Pandas and NumPy are they're all open source libraries, by the way, and you can check their websites. They have their examples and their tutorials on there. Pandas and NumPy are basic are libraries for data analysis. Matplotlib, Seaborn, Bouquet, and Altair are for data visualization, very important, not only for presenting your results, but for yourself as well, especially when you do some exploratory data analysis, but also beyond that. Also, we will be using scikit-learn here, or sklearn, XGBoost, Keras, and TensorFlow are for deep learning. We won't touch those. However, we will be working with some examples with sklearn. But what is data preprocessing? Data preprocessing is a technique that involves transforming raw data, which is usually noisy, incomplete, and inconsistent, to understandable and meaningful information. Usually data preprocessing comes after data cleaning and exploratory data analysis. However, some people include data cleaning in data preprocessing as well. Usually after you do some understanding from this data cleaning and exploratory analysis, you know more or less how you want to model your data. Also, it is very important, whatever analysis that you are going to do with your data, you have to do data preprocessing. So it's not only for machine learning models, but also for any other analysis that you have to do. First things first, you have to understand the data that you have. You have to look at it. The way you do it is you call .head method from Pandas. You have to check the columns that you have and the type of the data that you have in these columns by calling the attributes.columns and .dtypes, and also to do some basic statistics to see if what's the minimum and maximum value of this in this case numerical inputs, the mean, standard deviation, quartiles. However, you can do also basic descriptives for categorical variables. However, you have to transform first the text into categorical variables. And you will see usually the unique values that you have or unique categories that you have in that variable. The most frequent category and the frequency of that category. One of the first and the most important, I think, also the rest are very important, but this is important in the sense that it defines the size of your data set. As I mentioned before, the real data sets in real life, they are inconsistent, incomplete. So you will see that your data set might have some missing values, and you have to deal with those. To check the missing values, you call one after the other. Two methods is NA, which shows if the value is missing or not. It's a true or false, and then .sum that sums up all the missing values in that column. If you see that through that process, you see that you have a few missing values, you can remove all missing values by using drop NA method. However, if you see that you have more than you think you should be removing, that I would be cautious and not use drop NA, because you will have at the end a very small data set. However, I recommend to use .drop methods, and you can specify your rows that you want to drop or your columns by setting axis to 1 if you want to drop columns, and axis to 0, which is the default value for specific rows that you want to remove. You can also do filtering based on certain values, or if depending on a not null value as well. So if you are working with real data sets, they are usually comes with different data types. So you might have a column that is set to a data type object that includes both string and numerical data types. However, you think that this column or this feature is a numerical one. You convert it to numeric by calling the S-type method and set the data type to float. It can be, for example, you have a column for weights and heights, and you are sure that this should be numerical, not text. However, for other, depending on your data set, you have to make sure that the column type you want to convert to is representative for the whole column. Another step during the pre-processing stage of your data is feature engineering, and feature selection is another one, and data splitting and standardization. I'll continue with feature engineering. Feature engineering is when you create new features through the feature set that you have already in the data set. So it is highly dependent on the data set that you have. It usually explores different relationship between different features. For example, you have weights and heights, and then you can create a new feature called BMI by using the features height and weight. Also, extract and extend data. For example, you have a feature that it's text, and it includes, for example, among other things, it includes the grade of the cancer for a patient. Then instead of using the whole set of strings or information that is in the text data there, you extract only the grade number. So it's 1, 2, 3. And you create the feature including only the number. And some other examples are if you want to encode and you need to encode text data into numerical. Timestamps is another one, especially when you're dealing with time series problems. You have to convert first your date feature into date time, and then you extract the month in this case, but you can extract also the year or the date, depending on, of course, your problem. Another way you can create new features is when you have, for example, temperatures for different dates. However, you don't want to use temperatures for each day. You want to use the mean value, and then you create a new features. by applying the appropriate function using lambdas and applying it, setting x's to 1 so that you apply to each row. I mentioned that you have to encode categorical variables into numerical, and here is an example. You have patient ID and you have the gender of the patient, and you encode it using pandas, using the apply function, and you can also use it with you can use scikit-learn to encode it. And you can do it through label encoder by importing label encoder from the preprocessing module that scikit-learn has. You instantiate a label encoder, and then you feed and transform the column that you want to transform. However, this is valid only for variables that have 2 categories. For variables that have more than 2 categories, then you have to do one-hot encoding in scikit-learn or use get dummies method from pandas. I prefer to use pandas and then perform the rest of the fit the model in scikit-learn. However, it depends highly on your problem. In feature selection step or stage, you have the set of features, and sometimes data sets have more than 200 features, and not all the features are good for the problem that you want to solve, because either these features are noisy, highly correlated, or they are duplicates. So you have the same information in different features. In this case, you don't create new features. However, you remove some features. And in most of the cases, this improves also your model's performance. I have here 2 examples. The first one, when you have the city and the temperature for these cities. However, you have also the latitude and longitude for these cities. In this case, you have the same information. You have the city name, and you have the latitude and longitude of these cities. In some cases, you might want to use the city name. In other cases, you might want to use the latitude and longitude. However, it is not recommended to use both of them. For example, if you're doing some geospatial analysis, data analysis, then I might recommend using latitude and longitude in this case. Another case is when you have performed feature extraction, and then you end up with some features that are highly correlated. In this case, you have the weight and height, and then you have the BMI. If you are interested only on BMI, then you have to remove the height and weight. Otherwise, you don't need to do the extraction for a new feature, in this case, BMI, if you don't need it. After you have performed after you have done some data quality assessment, feature extraction, feature selection, then before you model your data, you have to do some splitting. So you have to train your model with training set, and you have to test your model with the test set. Otherwise, your model will learn the entire data set by heart and won't generalize well. And you have to validate your model as well in some way. With scikit-learn, you can do so by importing train test split from a model selection module. Some of the parameters in train test split are X, which is the set of features, and Y is the label or the feature that you want to predict. Test size in this case is the size of the test that you want to perform the testing. So in this case, is 20% of the entire data set is used for testing, and 80% is used for training. And stratification, in this case, is stratify equals to Y, because real data is not balanced, so you have to split your data depending on the variable that you want to predict. In this case is Y. There is a small example here with 100 samples. If you don't do stratification, for example, here, and you have the test size equals to 0.2, then there might be a case then all the class 1 samples will be on the training set, and all the class 2 samples will be on the test set, and the algorithm will be confused because it has never seen this data before, so it cannot predict well. So the outcome will be very, very bad. However, in most of the time, you need to standardize your data, especially because your model, not only the sklearn models, assume that your data is normally distributed. However, some of the features are on different scales as well. So you need to do standardization because it transforms continuous values, variables, data, and make it look more normally distributed. You do so using log normalization, feature scaling, etc. We will look at feature scaling after this. However, when do we need to standardize the data? I mentioned a little bit early. However, there are that the features might be in different scales, but there are two other cases when you need to do the standardization. First of all, if your model is in linear space, then you definitely need to standardize your data. Linear space models can be, for example, linear regression, KNN, K-means clustering, etc. Or if the features have high variance. You can do this with log normalization, for example. Feature scaling, as I mentioned, is when features are on different scales. What that usually do is that it centers features around 0 and transform to unit variance. This usually approximates to normal distribution after. In sklearn, you can use scalars such as standard scalars, robust scalars, quantile transformer, etc. Depending on your problem, you can use a scalar that it is useful for that problem. One small example here, for example, is we import standard scalar from the preprocessing module. You instantiate standard scalar, and then you fit transform your data. However, in this case, I converted it into two data frame because usually NumPy arrays are not visually beautiful to look. And here, it is practically the same example, but with standardization, when you standardize your data and when you don't standardize your data. This is very simple one. So you import necessary modules. In this case, we use a classifier called logistic regression from linear models. You import train test splits, and to see how the model does, we import a Cure score from metrics module. You perform the train test split. In this case, the test size is 0.3, so 30% of your data is in test set and 70 in training set. You instantiate the classifier, you feed the classifier to the training data, and then you predict the labels of the test data. You print the test accuracy and train accuracy, and you see that the difference is quite small. So our model is not overfitting. This is a good thing. Then the other example is then when we standardize our data before we train test splits it, and we fit and classify our data. We do so by, besides importing the modules that we imported before, we import the preprocessing module and import standard scalar. In this case, we instantiate the standard scalar, we fit our data, And in the train test split, we use the standardized data, not the data that we didn't standardize, and the rest is the same. And we see in this case, it is not such a big boost in performance of our data, of our model, when we standardize our data. However, in most of the cases, it does improve the model's performance. Here I have some resources for people who are new to data science, and so there are 3 books that I like them a lot: Introduction to Machine Learning with Python, Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow, if you want to go beyond Scikit-Learn, for example. And also Python Data Science Handbook by Jake van der Plas. There are plenty of courses online, such as in Coursera, Udacity, Udemy, and a really good one and free is also a machine learning crash course from Google AI. And DataCamp has also a lot of classes that are focused only on data science. There are 2 tracks with Python and with R. Depends on what language you prefer most. Some other resources are some websites that I think are good to know. And also I included here algorithmic fairness. I think it's very important to know what data we need to use for our algorithm and how to interpret them. There is a talk there, and there is also a book. However, I also recommend a book from Cathy O'Neill, Math Distraction, really interesting. Some resources for people who are not, have never programmed before with Python, or have programmed with Python, but for other reasons, not for data science. There are, for example, some classes for statistics, learn a little about it, regular expression, and SQL. And the last, there are some podcasts. I'm a big fan of podcasts. So during my commutes or in my spare time, I do listen a lot of podcasts. And these are some of my favorite ones, I'd say. So yeah, thank you. Oh, yeah. Okay. Question? I'll stop sharing my screen now, I guess. Okay. Okay.
Okay. Yeah, I can start with a question and
okay.
give some time to think about the question.
It was so quiet.
Yeah, thank you for the amazing presentation. I really liked your presentation. Now, the first question that I have is, people are saying that data scientist is the coolest or the sexiest job of the century. Can you please share your views on this? Why do you think studying data science is important? Or what kind of opportunities can this field open to people, to new students or to new professionals?
Okay, so first of all, data nowadays is everywhere. That's one of the main things why data science is like kind of a very sexy profession to have. However, you have to be careful because especially during this COVID pandemic, we've seen a lot of data scientists interpreting different data about COVID, and they're not using the right methods, or they're just interpreting the data as it is and do not have a background that actually interprets it correctly. So I think it's very important to know your data and to know the fields of this data that you get the data from. Otherwise, you will be interpreting the data as somebody that has no ins and outs, doesn't know the ins and outs of that field. And I think that is not correct. That is not good. However, I do encourage people to learn about data science and data analysis, because as I mentioned, at the beginning, we have data everywhere nowadays. And we need to transform this data into meaningful information. And the way we do so is by having people to actually work on that data.
Thank you.
Okay. Okay, I see there is somebody who asked, for this type of preprocessing, do you use Excel or another? No, I don't use Excel. I mean, we're talking about Python here, so we're doing all the preprocessing in Python. Oh yeah, yeah. Sorry, you have answered it already.
I have a question. Since you are working with medical data mostly, and I'm at my at the initial stage of my research, and I was wondering, how do you deal with imbalanced data?
Well, one way is, as I mentioned, especially when you're doing the modeling, you have to stratify it according to your, like, the value that the feature that you want to predict. That is a good question. I have imbalanced data as well. For example, I've been working with breast cancer electronic healthcare records, and I have patients, for example, who are male. However, they are only like 6% of my patients. So far, I've been doing my analysis as they are just patients, not actually thinking about the gender itself.
Because I saw a paper that came out of DeepMind that they were using auxiliary variables.
Okay.
Like having a categorical variable telling whether you are a male and female, and that will hopefully accommodate this imbalance during the training process. Well,
you already have that kind of information. So that is not like you are creating a new feature out of the blue, because you are already given, be it from the electronic healthcare system, or in your case, for example, from an app or something, because people usually insert this kind of information. However, I haven't read the paper, so I cannot talk a lot about it. However, I'll keep that in mind, and might be good to read.
Yeah.
As a researcher, you have to read every time. Sometimes you get bored of reading other stuff because you've been reading a lot. But I'll keep that in mind. Okay, any other questions here?
And the other thing is, do you use mostly like your personal computer, or you use some like services online on the cloud? Or
no, I have actually two different computers, both from different institutions. So I have my computer from University of Deusto, and also I have another computer from the company, because they paid for the data set, and so I'm using their computer. However, the data set itself, I am using a server, because even for that, I cannot use any computer. So I have to be careful, and I cannot share the data even with myself, store it somewhere. So I have to use the server. So if the server is down, then I have to do other stuff, not work with the data. And especially during this time that everybody's at home and working from home, so the internet is kind of slow. So sometimes when the internet breaks, your connection also breaks. So that is a drawback.
yeah, I understand, because yeah, it's kind of expensive to buy the GPUs and all the.
No, I actually have a computer at my university. I'm using my university laptop. However, I do have, because I've been working with images as well, although I talked here for tabular data, but I've been working with images, again, specific to medicine and cancer in particular. And I do that kind of training and testing in there, because that's usually require a lot of GPUs, as you mentioned.
Mm-hmm.
and with your laptop, you cannot do much.
Hello.
Hi.
Yeah, I thank you very much for the very nice presentation. I really enjoyed it. I have a question that I hope you can, give me some insights on it. So you mentioned that you are working on medical data.
Yeah.
So I'm assuming that by default that contains a lot of sensitive information.
Yes.
So how do you ensure or approach to the problem of data privacy? So in this case, how do you ensure that the model, your model, is actually learning? For instance, in the example you mentioned earlier, it's learning only about breast cancer and it's not unintentionally, let's say, learning something else about the patients, which can be later on leaked.
Okay, so the way I get the data is through a relational database. And what I've been doing is I'm separating, first of all, because I'm working with both breast cancer patients and prostate cancer patients. So I have the information all there mixed up together. I'm not sure if you've ever worked with relational databases and how.
Yes, I have.
Okay, perfect. So what I'm doing is getting the information from this database using, of course, SQL, and then filtering it only with the breast cancer patients, for example, not prostate cancer patients. And then I'm using that file after CSV usually for my data for pre-processing and analysis. So I'm dividing, first of all, the data for cancer patients, breast cancer patients, and prostate cancer patients. And then I'm collecting only the information that at the moment I need, not the information that I don't need. And then I'm doing pre-processing separately, both for breast cancer and prostate cancer. I don't know if I answered the question.
So you do your filtering beforehand.
Yes, yes,
no,
yes.
I was wondering whether you like to ensure privacy, you rely on for instance differential privacy, which will ensure provable guarantees that you are not leaking information. So yeah. I was wondering whether you rely on those. And then a follow-up question would be on the fairness. What is your fairness? What is your take on fairness in AI today?
Okay. So to answer the first question is that when you sign kind of a contract with the institution that shared the information, you say that you cannot disclose it with anybody. I'm not even disclosing with my supervisor.
Hello.
Oh, hi. It froze for a second, so.
Yeah, sorry, we had the technical problem.
Awesome. I think
you are muted.
The speaker is on mute. Yep.
Sorry, yes. Can you hear me?
Yep.
Okay, perfect. So to answer your first question, when I applied for the data, you usually apply, so you get permission, and you have to sign an agreement at the end that you will not share it with anybody. And of course, I have to abide by that contract. Otherwise, well, they can sue me or anything. So I'm not even sharing this data with my supervisor, with my PhD supervisor. So you are not allowed to do that. And as I mentioned, I'm not even allowed to download any data on my personal computer, definitely not. But even in the company that paid for this data set, I cannot download it in their laptop. So I only access the data through the server. Regarding the fairness, a lot of talking has been going on, especially in US. So I've been following that a lot, and especially how you use certain data, for example, such as gender, race, that is highly sensitive. You can use such information, for example, in medicine, but you have to be careful when it comes to other applications, such as job applications, for example, or loan applications, or even the famous one is in criminal justice in US. I haven't seen much here in Europe, I must say that. Most of the talk is happening in US, and I'd like to see how that fares here in Europe. I'd like to see more people talking about it in Europe. Again, here in Europe, we have the GDPR, which kind of is like the police in everybody's mind. So that kind of puts people into like, you know, you need to be good, kind of like you need to act good.
Yeah, true. But if your data set is biased, that will transfer to your model as well. That's the thing. So that's I say that's the trade-off, or the issue that is now when it comes to discussing fairness in machine learning.
There is a saying that everybody says, that garbage in, garbage out. So if you put garbage, you cannot expect your algorithm to suddenly like, because people have been using deep learning everywhere and everywhere. But I mean, it can do as much as it can. I mean, if you put really bad data, biased data, then of course the algorithm will be biased. I mean, the machine itself won't be biased because you put like they learn the data.
They learn from what you give.
Exactly. So yeah. So you have to be careful. That's why I say pre-processing is one of the main steps before doing anything in your project. If you have, for example, 8 months for your project, I guarantee you have to deal, like, if not 5 or 6 months, you at least 4 to 5 months you have to work with data pre-processing. I mean, it's one of the most important steps for any data analysis. If you've done a very bad pre-processing job with your data, then, I mean, of course, you will get a very bad outcome at the end.
Sure. Awesome. Thank you very much.
You're welcome. Thank you for your questions. Okay, some questions here. Okay, there is one feature in sklearn, imputing. I'd like to deal with missing data myself because I know the data better than the algorithm. So if I know, for example, that missing data is because it should be missing, then I have to leave it as is. However, if the missing data is because somebody in the hospital forgot to insert it, then I have to look, for example, with medical data, it's very important. Each record is not unique. So the same patient can be in different records. You have to see different records for the same patient and check if there is any problem, especially on that record, and you can use other records, or you can, for example, for weights and heights, you can do an average. However, if you see that one time the nurse, instead of putting 170 for the height, it puts 0, then of course you have to check the patient by the specific patient ID number, and then see what's the other numbers for the same value, for the same column, for the same feature in this case. And then work with that, not with the record that was missing. However, for other problems, it could be definitely another case. Did I answer the question?
I have a last question.
Okay.
How do you determine whether you have enough data for the task at hand?
My first study for my PhD was in Dublin, where I collected my own data. So I conducted a qualitative study, and I knew that I could not do any machine learning with 80 patients, although the data was quite broad, and I had plentiful of data from these patients. However, there were very few records, very few patients in this case. 83, it's very few. You could do some good analysis with 50 records, 500 records, sorry. However, I would recommend definitely above 1,000. 10,000, 20,000 would be good. Because you're doing also training and testing, because you have to validate your model. Otherwise, that's not a model. That's not a good model. I cannot hear you.
I was thinking whether you see some statistical properties, like you see if the variance doesn't change anymore if you add more data, or I mean,
well, at some point, I mean, with deep learning, then the more data, the better. I mean, yeah, everybody says that, because you will have I mean, not you as a person, but the algorithm, the model, will know certain features that you might not get with your, like, just going through the data, and might make some different feature extraction, for example. However, I think above 1,000 would be a good number, definitely.
Okay, good to know. Because I'm like I have only like 20. I'm still collecting, but yeah, I just want to know where to start, like testing, and then continue collecting.
You can do, if you have, for example, 100, you can still do it, and it might give I don't know what kind of result, but I mean, the more the better, definitely. Above 1,000 would be a good number if you are doing a good analysis.
Okay, thanks, good to know.
For images, you could deal with less, because you could do also image augmentation. That is one thing you can overcome this small data sets. Yep. There was a time that there were a lot of people talking about one-shot modeling. Like, this is in deep learning, not as exactly machine learning. Learning only by one example. However, I haven't looked at it further, so maybe you might find it interesting.
I'll have a look, but yeah, probably not at the moment.
And another thing that I would suggest is, because there are a lot of parameters that you are working with when you are modeling, so you have to try different parameters for each classifier, for example, algorithm, or you have to do also ensemble learning and try to see. Usually ensemble learning is when you have different algorithms predicting the same, of course, the same label, but instead of everybody predicting whatever they want to predict, you combine different results from different algorithms, and then they vote together. So if you have a classification problem, then usually if all the algorithms have said that this is class 1, then you're sure that that is class 1. If 2 out of 3 algorithms said that that is 0, then the vote is 0. So that is in class 0, and so on, depending how many models that you are training at the same time. These are sometimes called estimators in scikit-learn as well. And then you have to, XGBoost is quite popular nowadays. It has given some good results in different problems. You can give it a try. It's not implemented in scikit-learn. However, they have their own library and you can install it. It's very simple to use. It's practically the same as scikit-learn. And you you call all the modules that you want to use in your model from scikit-learn, but the model itself is in a different library, as XGBoost, Extreme Gradient Boost.
Yeah, well, in that respect, we are not allowed to use scikit-learn because we don't have like control of everything there, but we have to do it from scratch ourselves to have it like,
okay,
because it's like, you know, policies and stuff like that.
Okay, I see.
Okay, so yeah, maybe we can take some other question, and you guys, if you have some of your other question offline.
Okay.
Okay, so Ornela, there are like three questions that someone has asked here. Higla is asking, I have a question about handling missing data, inputting or removing. Which one is more preferable?
Well, I think it depends on the type of data that you are working. I think I explained it a little bit earlier when I was talking. You have to learn the data. If you don't know the data, then I mean, it depends on it. I cannot say if, however, I discourage everyone to remove missing values because you are shrinking your data set so much, and then at the end, it might not be valid for any kind of analysis. So be careful what you remove. That's what I say. And I don't use drop NA like nothing. You know, I have to be very careful. Okay, some information about my experience as a Marie Curie. I am actually doing another presentation later this month about that, my experience in Marie Curie. You can, I will share that in my LinkedIn. So if you follow me there, you are more than welcome to join that webinar. I would say this, that it has been quite good, but also challenging. Good because you get to collaborate with people from all over the world, first of all, and you get to experience working in different settings and different countries. And my project is an interdisciplinary project, so I got to learn from people from with the background in sports science, in physiotherapy, in psychology, in business. So you get to tackle the same problem from different perspectives, and you learn to think of that problem with different hats. So that was really interesting. Can you share some? Okay. How do you decide what technique to use when working with categorical data and imbalanced database? Categorical data. I mean, data, when you get the data set, data is not categorical. You make it categorical. If you think that that kind of information is in categories, for example, gender, male and female, or I don't know, some other, because now everything is coming from the medicine background. But for example, marital status or education, these are categorical. Usually, when I transform these features in categories, I know that I've done some research that these are the main categories. And usually you extract them from text data. And you have to work a lot with regex, so regular expressions. And you just get dummies afterwards to encode it. So that's the way I've done it. I haven't used one-hot encoder. I prefer to work with pandas more. Imbalanced data sets, databases. You have to know what kind of like information you want to what features you want to predict, because your data set might be in balance for certain features and might be balanced for certain ones. So that depends on your database. I'm sorry, guys. I say over and over again, it depends, because it really depends on your data.
Okay, thank you. Yeah, one last question before we end this meeting for today. So is there like any other question? The last one.
I have one. Okay, so I'm getting the last one.
Okay.
Yeah, thank you again. For sure, you are a role model in computer science. Actually, I have a question composed in parts. First, what do you consider your biggest success in your short but very filled and successful career? And second, what is your advice for young girls who want to kind of study and to dig deeper into computer science?
The biggest success, I think I love learning. So for me, everything that I do is because I am passionate about, and I really enjoy learning whatever I set my mind for the next phase in my life. So I think at the moment, I definitely think that finishing a PhD is kind of a very big part and big success, because I mean, you've been working in the same problem for 3 years. In my case, a little bit more than 3 years now, and it drains completely your energy, your mind, your everything, and you're giving your everything to that solving that particular problem. So I think this will definitely be the challenge, the most challenging, and I'm definitely proud of finally finishing it. What I suggest to young girls, definitely go for anything you set your mind on. Especially in Albania, don't think what other people. I think this is everywhere, though. I've seen it in all the countries I've lived. There are some mindsets, for example, or the culture of the people in general is that engineering and STEM in general is not for women, which is completely wrong, because computer science field started with women. Yeah. And programming started with women. So I encourage everybody to start programming, just even a little, very little. Start with HTML, CSS, or like any other simple programming languages, and build on that one after the other. I've been working mostly alone, meaning that PhD itself is you work quite alone. However, I like when people ask questions and you answer, because you learn by answering other people's or from questions. So I encourage everyone to, if you don't know something, you just ask. I love Stack Overflow. I love Stack Exchange. I think everybody should go online and just try, give it a try. Then if you don't give it a try, then how do you know if you don't know it, do not know how to do something? Because you haven't given a try to learn it first. So give it a try to learn something and work on that. There are a lot of data sets online, for example. You can just try with one of these data sets, and Kaggle website has different competitions. You can just go there, create an account, and pick any problem that you want to work on, and then you just try it. This is my advice to everyone. Just try it. Give it a try. You never know where you might end after.
Yeah, no, yeah, I think it's the perfect advice. Thanks.
Okay.
If I add may I add something?
Yeah.
Yes. Sure.
I would like to recommend for others who are a bachelor to go at KU Leuven and to apply for a master in AI. It's a very good program, and it's cheap, given that other universities, they charge non-EU citizen quite a lot, and there you get like the same fee. And it's a very good program, and it's very focused on machine learning and computer vision, and it's on the field. So there is no need, as far as you know math, and that will be enough to take you all the way to the end.
Perfect.
Okay, thank you for sharing this information. I believe that for everyone that is interested in data science or in artificial intelligence, it is like very helpful information. Okay, thank you for everyone that joined today, and a big thank you to Ornela that has joined us today and has shared their information with her experience with us, and also her presentation regarding the data preprocessing with Python was very interesting. I see that someone is also writing questions now, but I'm sorry that we cannot answer all the questions today. If anyone has very specific questions regarding what Ornela has just explained to us today, please reach out to her. I believe she will be very willing to help you and to answer. Okay, thank you. And also we started today with Ornela, and it was like a pleasure for us to have her here. But we will continue with other role models.
I've shared my screen just so everybody have my contact, so you can contact me either in LinkedIn or Twitter. I'm very active in Twitter as well, so you can follow me there.
Okay, so great. And also for everyone that needs to follow up with Women Techmaker and the other events that we are going to present in the future related to the Albanian role model in technology, I will again just paste also here in the chat the information. Please follow us in Facebook, LinkedIn, or anywhere. And in the future, we are going to share with you other Albanian women, very successful, and also role models. Thank you for today.
Okay, yeah, and just a final spoiler. So our next meeting would be on 16th of June, and we have a very special guest. So Yona Babi from Stanford University will join us. So please join us again in our next meeting and spread the word and invite more friends to be part of this series of kind of knowing and getting inspiration from very successful women in technology.
Okay.
Thank you guys. Bye.
Bye.
Bye.